Welcome to the seventh episode in this workshop on the introduction to R for geospatial data. In this episode, we will provide an introduction to visualization, specifically using the package ggplot2 to generate some basic figures and using some of the commands and functions that we will see when plotting the geospatial data. So for this episode, you'll be able to use the ggplot2 package to generate histograms and bar plots as two examples. You'll learn about geometries and aesthetics and apply those layers to create a custom ggplot plot. And you'll manipulate the aesthetics of a plot using different colors and position parameters to more fully customize your plot. And so to start off with, let's just think about why we would want to do visualization. So why we're even talking about this. And it might seem obvious when working with geospatial data that sometimes you want to visualize that spatial data. But visualization is important for any kind of data because it's easy to see patterns in your data when you visualize it, especially if you have some control over which parameters you are visualizing and some manipulation of the data using things that you've learned, such as in the dplyr package. So it's really useful for data on its own, and it's also exciting that ggplot2, the package that we'll use for visualization, can also work with geospatial data and be able to inherit some of the characteristics of spatial data that will make visualization and creating figures and maps quite easy. And so for this workshop, we're going to focus on using the package ggplot2. I don't know if there's a ggplot1, but there's a ggplot2, and that is a good alternative to the base plotting system in R. You can certainly use sort of the base plots in R, but ggplot2 is more customizable. The syntax is pretty easy to learn, and it's a great option, especially because of the geospatial features it can recognize. So we are going to work with the same data and we're going to work in RStudio again. So you should have your R geospatial folder and we're going to use that same R project file. So we're still working with the project and in our environment. So you'll see here I opened R from the R project file. And I am going to just quickly make this look a little bit bigger. Okay. So this is our RStudio environment. We're going to create a new script as we have done for all of these. So using this menu here to create a new R script. And there's no rules for how you create this, but it's generally best to have things at the beginning. So you have some sort of title, a date, and your name. So introduction to visualization for geospatial data. We'll say June and your name. And then let's save it in our folder. And so because we're using our R projects, we're going to put it in our scripts folder. You can give it a easy to use name or easy to recognize name. I'm going to call this plot ggplot2.r. Okay, so now it's saved as a script in our folder. Let's bring in the data that we have been working with and let's load in our packages. So load data and packages. Let's first load the packages. So we're going to use a function library to call the tidyverse package that we have been using. So that'll load a suite of packages for manipulating data. And we'll also load the new package, ggplot2. Now, if you haven't already installed this, you'll have to first install it as we have done with installing other packages. So you could do that by going to your menu and doing install tools, install packages, or you could do it in a scripted environment where you tell it to using the function install the packages. I already have it installed, so I'm just going to call it here. Okay, so let's run these two, and we get just messages that everything has been installed. And then for the data, we're going to use that Gapminder data set. So Gapminder, I don't have it loaded here, so I'm going to load it into my environment and in this script. So Gapminder, we'll use the function read CSV. And remember, this is in our data folder. It's in our data folder, and I'm using the backslash and then tab complete just to find it because it didn't pull up, and using my arrows to select and go down to the Gapminder underscore data CSV file and tab complete just to select that one. Okay, so that is so now we have our packages loaded and now we have our data set loaded. So we can get into working with the data. Let's first create a histogram of some of the Gapminder data. So as a reminder, we have this Gapminder data set. It's many observations. It's 17,000 observations with 6 different variables. And the variable names are here: country, year, population, continent, life expectancy, and GDP per capita. So let's plot the life expectancy as a histogram. So it's the frequency of different life expectancy values. So we can do that with some ggplot syntax. So let's first fill out the full ggplot code or code chunk, and then we can walk through the different parts. So we're going to plot life expectancy with ggplot. So to start any ggplot graphic, or the most common way you'll see it is using the function ggplot parentheses. And within that, we need to tell it what to plot. So we have the argument data equals Gapminder, comma, we're going to add some aesthetics, AES, parentheses, where we can give it the x-axis. We're going to say x equals LIFE, capital EXP for life expectancy. This life expectancy is a column in our Gapminder data set. And then just arrow over outside of the final 2 parentheses because we're going to add a plus sign. So add a plus sign, hit enter, and then we're going to add a geometry. So you're going to say GEOM underscore histogram, and then a set of parentheses. So let's run this and then we'll talk about it. So this is 2 lines of code. You'll see R is throwing an X. I think that's okay here. And then to run this ggplot code chunk, you can either put your arrow at the end, at the beginning, have it in the middle, or you could highlight everything. So lots of ways to run it, and it should run both lines together. Okay, there we have our first figure where we have life expectancy plotted as a histogram. So we have the count of values on the y-axis. We also saw we got a warning here. It's in red. It's still ran, but we got a warning saying stat bin using bins equals 30. Pick better value with bin width. So this is something you'll see really often. It's just saying, hey, we have a default value of 30. You can change it using bin width. Okay, so what did we just do? This was probably new syntax, but let's kind of break it down. So ggplot works as layers. So you basically tell ggplot to first plot, give it the background, give it the base, and then you add in the data that you want. So you give it the base, you add in the data, you add in the aesthetics, and then you tell it what kind of figure you want to plot. So let's do just the first part. So we're going to break it down. Let's run this first line. So let's just say, let's just set up our plot. So we're just going to do ggplot parentheses. Within the parentheses, we're going to use data equals gapminder. Okay, so we're telling it to plot the gapminder data, comma AES parentheses. Now these aesthetics are kind of the details for what will go into the plot. So we've told it we want it to plot the gapminder data, but it doesn't know yet what it should plot of that data. So with this AES, or this aesthetics argument, we need to tell it what to plot. And with a histogram, we only need to tell it to plot on the x-axis. So we're going to use the argument x equals LAFE-EXP. And so again, we're pointing to that life expectancy column in our data. So if we run this, we'll see our plot updated here on the right. So we have this blank plot where we know there's life expectancy with some awareness of the range of values. So R is getting it ready for us. But because we haven't exactly given it the details like we want it to plot a histogram, it doesn't know. It's just saying, okay, I'm putting life expectancy on the x-axis. Please tell me what to do next. So let's add the histogram geometry. So we'll do the same thing, ggplot parentheses, data equals gapminder, comma AES aesthetics, x equals life expectancy. Okay, we're going to arrow out and we're going to do a plus sign. And so that plus sign is telling ggplot, hey, there's more coming. Don't just run this line. There's more coming. So we'll do a plus sign, hit enter, and we'll start a new line. On that second line, this is where we're going to tell ggplot which geometry we want. And geometry is just sort of like, what type of figure do you want? There's other things that you can add. You can add like annotations, or you can add, titles. Those have different, function names, but we're adding a geometry as a type of feature to this figure. So on this line 20, we'll write GEOM underscore histogram, and then parentheses. And we don't need to add anything just yet into this histogram. There's certainly more you can add. But now ggplot knows it's using the gapminder data. On the x-axis, it's going to plot life expectancy, and it's going to use the histogram style for a plot. So it's got everything it needs to make a basic plot. So we should get the same thing that we did before. And there we go, our histogram of life expectancy. Let's do a challenge to exercise your new ggplot skills. So the challenge will be to plot the GDP per capita using a histogram. So plot GDP per capita. So go ahead and pause the video and come back when you're ready to see the answer. All right, how did you do? Let's plot GDP per capita. So let's start off the same way. ggplot, parentheses. Data equals gapminder. We're plotting them with the same data frame, comma AES. We'll still have an x equals, and here rather than life expectancy, here's where you should put GDP, capital PERCAP. Arrow outside of the final two parentheses, plus sign, enter, and then we'll do the geom histogram again. Okay, so I got an error when I ran this. Maybe you did too. This error is saying object GDP per cap not found. This is so common, and it's a good thing to highlight because what you put in this x-axis, it doesn't autofill. So it's one of the kind of annoying things about ggplot where it doesn't autofill, and you actually have to know what this column name is in your data frame. And I spelled it wrong. So I said GPD. So I'm going to say GDP because that should be right. Again, this needs to match exactly what's in our data frame. Okay, let's try it again. Okay, there we go. So a simple error to correct. So here we have a histogram of GDP per capita. The data looks different, but everything else about the plot is the same. All right, let's move on and combine some of the stuff that we've done in the previous episodes where you're filtering or sort of playing with the data that you want to then plot. So we'll still do some ggplot graphics, but right now we're going to make a smaller subset of the data. So we're going to actually subset the data and just look at the data from 2007 for the Americas. So let's create subset for 2007, the Americas. How do we create a subset? Well, think back to our dplyr skills. We're going to use the function filter, using filter. Let's rename this data set and create it as an object. So we're going to say gapminder underscore small, just as something easy. The assignment operator, and then the function filter, F-I-L-T-E-R, parentheses. Within that filter function, we need to tell it which data to filter, gapminder, comma, and then the arguments we want to, or the column names we want to filter by. So we want to filter by the year, where year equals, so it's a conditional, year equals 2007, comma, continent equals, Americas. Again, year and continent are columns in our data frame. All right, now we have a new object or an environment. It's only 25 records, and we can plot that. So let's just look at the gapminder data set. And we're also going to look at a different style of ggplot. So we're going to create a bar plot of the 2007 data for the Americas. All right, so let's do a ggplot code chunk. So ggplot, parentheses, data equals gapminder underscore small, because we're plotting our newly created data set, comma, AES, parentheses. Here, because we're doing a bar plot, we need to tell it the x-axis and the y-axis. So we're going to have two arguments. So AES, aesthetics, x equals country, y equals GDP per cap. So we're plotting country by the GDP. Arrow outside of parentheses, do the plus sign, hit enter, and now our geometry, GEOM, call. Geometry call parentheses. Let's run it and then we can talk through it. Okay, so here we have our bar plot where we have country on the x-axis, GDP per capita on the y-axis, and a bar for each value, for each per capita value for each country. So we've done that by specifying the aesthetics, the data, and then using this geometry for bar plot or column. It's a, they call it column call is what they're defining here. But this isn't a great figure because look at how squished these country names are. And so there's a variety of ways to deal with that. But one easy way is to add another argument to our ggplot. So we're going to add an argument that switches the x and the y axis. So we're going to take this same ggplot code chunk, and now we're going to add to it. So we're going to add another line or a new condition for creating this ggplot figure. And to do that, we're going to use the plus sign again. So on line 31, outside of the parentheses, we're going to add a plus sign and say, hey, R, keep going, keep reading the code below. And on line 32, we're going to add the function COORD underscore flip, FLIP parentheses. So that stands for chord flip. Well, it's chord flip, but it's the coordinates flip. So it's flipping the X and the Y coordinates, or the axes. And so when we do that, nothing about the data changes. It's just now GDP per capita is on the x-axis or along the bottom, and country is along the y or up and down here. And so we didn't have to change anything about the labels. All we did was flip those, what's on which axes. This is something you could do by changing x and y up here, but there is also a function for it. Okay. Let's do another challenge to continue to build your skills. So for this challenge, we're going to do a couple things. You're going to want to create a new data set where we have another subset. We're going to still look at the Americas data, but we're going to look at 2 different years. And then we're going to plot those data for each country for 2 different years, but have those bars be separate. So we want a bar plot, and for each country, have the GDP value for 2 different years. And we're only doing this for the Americas. So we're going to plot. So we're going to create a bar plot that shows the GDP per capita for all countries in the Americas for the years 1952 and 2007. So you could take away from this challenge, like, how has GDP for the Americas changed in those 60 years? Okay. A little hint, you're going to want to first filter your data to create a new data set, and then you're going to want to plot it. So pause the video now and work through this challenge and come back for the solution. Okay, let's do the solution. So I said we're first going to need to filter the data or create a new subset. So let's call this gapminder small underscore 2. We're going to use the same filter function. And what are we going to filter on? Well, we know we want continent to be the Americas, and then we want 2 different years. So we want 1952 and 2007. We're going to do it slightly different though. So we're going to use, remember, the pipe operator, where we can combine different, we can use the dplyr functions, and we can sort of stack them together. So we'll first call the gapminder data set, and then we're going to use the pipe operator, where we do the percent greater than percent, and then the filter function. And doing it this way allows us to pull out the gapminder, so the first argument doesn't have to be our data set. So we're going to do everything the same, except now we're using this pipe operator, where we're telling R to say, with the gapminder data, do the filter function. And this comes in handy when it's for more complex sort of filter operations. Okay, so within the filter function, we're going to say continent equals Americas in quotes, comma, year, percent in percent, C, parentheses, 1952, comma, 2007. Okay, so we did a couple things here. So we have the continent equal Americas. So I got an error that was wrong because I didn't use equals equals. So we want this to be a conditional, where the condition is that continent equals the Americas. And then our second condition is year, where we want the years to be, where we want to pull out 2 different years. So we're using this percentage in percentage to say year where it could be these 2 things. So this is how we tell R to look into year and look for 2 separate things. So now we have our data set of just the Americas data for these 2 years. You might have gotten about this in a different way. If it works for you, that's great. But this is how we can use the filter function to do it. So let's create our ggplot with just these data. And again, we want to create a bar plot of the Americas data where we have 2 separate years. So we're going to start how we always have started, ggplot. The gap minder small 2 data set, comma, the aesthetics. So we said we wanted to do country and GDP per capita. So X equals country, comma, Y equals GDP, capital PERCAP. And then because we want 2 different years, we need to give it that information. So we're going to use another aesthetic called fill, F-I-L-L. And we're going to say fill equals the year. And we're going to do a special thing where we consider it as a factor. So it's a categorical, not as a numeric. So we're going to say as.factor. So we're going to quickly switch the type of data as factor year. Okay, there's a lot going on there. Let's first run this just to see how that looks. Okay, like we saw before, ggplot created it, country on the x-axis, GDP capita on the y. It doesn't know what to do next, but at least we got that far. Let's do the plus sign, enter. We know it's going to be a bar plot or a column, so we need to do GOM underscore col, parentheses. Plus sign, enter, and we know that we want to flip those coordinates, so let's do CORD underscore flip, parentheses. So we know we want to do those things. So let's add those on and see what we get. All right, so now we flip the parentheses, we flip the axes, we have our year, we have our data, and now it's presenting itself where we have each bar stacked on top of each other. And so we have the 2007 bar and we have the 1952 bar. And this is some defaults that ggplot has added. So as soon as we had this fill, it's like, okay, we know we want to do have both of those years represented. So it's going to put a legend, and it's by default using the argument to stack these bars on top of each other. Now, that doesn't really work very well because we can't compare the size of the bars. If it was something like a total that you wanted to see, that might be useful. But we really just want to compare the magnitude of these bars. So what we'll do, and I'm just going to copy and paste this so you all can see. So I'm going to copy and paste this full set of ggplot code. We're going to show the bars side by side. And we'll do that by adding another argument to the geometry, the bar column geometry, where we're going to say position equals, and in quotes, dodge. So we're adding some more details to this geometry. And let's run that. So our plot changed, and now instead of the bars being stacked, they are side by side, or they're sort of dodged. They're offset from one another. And now we can see much more clearly countries that have, a change in the bar size or a change in the GDP per capita for the different years. So places like Canada, the United States, Puerto Rico, There's no red bar that's bigger than the blue bar. So that's an interesting way to look at the data. Okay, so you've successfully created a pretty good looking ggplot figure where we've learned how to do a histogram, we've learned how to do bar plots, we've looked at different variables and how to add color to plot different variables, and how to put things on different axes or change those axes. So there's a lot more customization that you can do by changing the arguments in some of these functions. Um, if you are into this and you want to learn more, there's a whole other lesson on this, data visualization with ggplot, and you can get into more examples of data and how to customize them further. But for now, these are the types of things that we will need to use for our for plotting the geospatial data.